This is part 3 of section 4.5. In this case, we have a logistic growth function. It is f of t equals 100,000 divided by 1 plus 5,000 e to the negative t. This describes the number of people, which is given by f of t, who have become ill with influenza t weeks after its initial outbreak in a particular community. Round to the nearest whole number for these problems. Okay. How many people became ill with the flu when the epidemic began? Well, when it begins, that means time is equal to 0, right? 0 weeks after the beginning. So let's see what we get when we plug in t0. So f of 0 will equal 100,000 over 1 plus 5,000 e to the negative 0. Okay. Well, anything to the 0 power is 1. So what I have here is 100,000 divided by 1 plus 5,000. 5,000 times 1. Okay. So this is equal to 100,000 divided by 5,001. Okay. So what is 100,000 divided by 5,001 is about, we're supposed to round to the nearest whole number, so it's about 20. Okay, so approximately 20 people had it in the first week when t was 0. Okay, now how many people were ill by the end of the 4th week? Okay, so in this case, our t value is 4. So all we need to do is to find f of 4. So this would be 100,000 divided by 1 plus 5,000 e to the, it's negative t, so negative 4. Okay, let's see what this equals. I'm going to be very careful and enter all of this in the calculator. So starting a fraction, I have enough zeros here. 100,000, yes. 1 plus 5,000 e to the negative 4. Okay, so I have about, let's say I have 1080.167, so on. So we're supposed to round to the nearest whole number, so approximately 1,080 people. Okay, now what is the limiting size of the population that becomes ill? Well, this is what I was talking about in the part 1. This is a hard problem if you make it hard, but it's really easy. C is the limiting size. That's it. So what's in the C position? C is in the top. What's in the top here? 100,000. So 100,000. You can't have more than 100,000 people ill, perhaps because it's in a particular community. Maybe the community only has 100,000 people in it, so you can't possibly have more than that. Okay? It's whatever real world consideration puts a limit on this particular kind of growth. Okay. Now for some problems that look a little bit scarier but are pretty darn easy. Okay? First thing we're going to do is we're going to rewrite the equation in terms of base e. Then we're going to express the answer in terms of a natural logarithm, round answers to 3 decimal places. Okay? So what we're using here is this, which was at the bottom of the first page of your notes. Y is equal to a times b to the x is equivalent to this. Well, let's just look right here and do some pattern matching. I have y equal to a, so my a value is 1,000. My b value is 7.3. Okay, so now let's rewrite this using this. Well, this will be y is equal to 1,000 e to the natural log of 7.3 times x. This is the first part of your answer. We've expressed it in terms of a natural logarithm. Now they're going to ask you to rewrite it using rounding to 3 decimal places. And really what they're asking you to do is to calculate natural log of 7.3 to 3 decimal places. Okay, so let's find that. Natural log of 7.3 is 1.87, so on. So I'm going to round this to 3 decimal places. So that would be approximately 1.988. Okay, so this is the first part of your answer, and then they're going to ask you to rewrite it using this value instead of this. So you have y is equal to 1,000 e to the 1.988x. That's it. Okay, now we're going to do the same thing for this problem. Our a value is 4.5. Our b value is 0.6. So if we use this, we can rewrite this as y is equal to a, 4.5, e raised to the natural log of b, 0.6, times x. This is the first part of your answer. And then they will ask you, of course, to round to 3 decimal places. So let's go off here and find out what natural log of 0.6 is approximately equal to. Well, it's approximately negative 0.511. So you rewrite that last equation as 4.5 e to the negative 0.511x. And that is the second part of your answer.